Hello, everybody, and welcome to today's webinar, Diagnosing Diesel Engine Mechanical Issues in 15 Minutes or Less. Thanks for joining us today. My name's Amanda Goyette. I'm an admin assistant here at AERA, and I'll be in the background today helping moderate today's event with my colleague, Rob Monroe.
Hey everyone, Rob Monroe here. I look after membership and technical development at AERA. Just a couple quick housekeeping slides here before we bring Chris on. For those of you that do use social media, AERA is on all of our active social media channels. So we're on Facebook, we're on Instagram, we're on LinkedIn, we're on X, but we also have a private Facebook group page for all of our members. So I would encourage you to go check that out. If you just go to AERA and type in AERA members, you'll find our private page. And again, it's members only, but this is a great page for maybe you've got like a really oddball part that you're looking for, or a piece of equipment that's giving you some grief and you got some questions and stuff like that. It's a member helping member page, and you can't go wrong with that kind of information. It's just all of us are in the same boat. A lot of times we have issues or questions or running into challenges that we need some help on. So I would encourage you to get onto that private page and get into that and have a look. If any of you are going to be at the PRI show this December, we would really encourage you to come in a day early. We're doing another one of our engine professional industry conferences. So it's a full day event. It includes breakfast, it includes lunch. You get 4 high-level technical presentations for the day. You definitely come out of there with a wealth of knowledge, and that's on the Wednesday, December 10th. So that's the day before the PRI show starts. So get over to our website there. We've got the web address there, the aera.org/epic. You do need to register for that one. So we've got more information coming pretty quick for that. We'll be able to get you all registered up, get you onto that. So we encourage you to do that, and we'll see everybody there. So like I mentioned, this is a real treat for us. I mean, Chris Hamann from Lakeland Auto Machine, he is our guy that we talk to when we need a diagnostic question as well as a marine question. And Chris has put together a package today talking about diesel engine mechanical failures. And as any of you know that have ever worked on diesel stuff, especially under hood, it's not a lot of fun. It's a back-breaking, dirty job. And Chris is going to show you a couple little tricks today how you can be testing some of these mechanical failures without getting too terribly dirty and too terribly sore. So, Chris, I'm going to put things over to you, but how are you doing today?
I'm doing excellent, Rob. Thank you, and thank you, Amanda. Thanks for having me. So we're going to go ahead and get started. Thank you guys for tuning in. I put together a little presentation today, and we're going to talk about diagnosing engine mechanical issues in 15 minutes or less. I know it sounds like a scam, but I'm promising it's not. So just a bit history on me. Some of you know me, some of you don't. We have a repair shop, machine shop. We mostly work on vehicles. We don't do any on-boat work per se. We overhaul a lot of engines, and I do some diagnostic assistance with marinas with the Pico scope. So we've got our own little marine training thing going. So I do a lot of that. I'm not going to read all this to you, but my email address is right here. You're more than welcome to reach out to me with any questions or anything about anything I say or talk about today. I got a few goals, and my goals today is I'm going to do a quick, brief introduction of Pico scope and how we can use it to acquire engine mechanical data non-intrusively. Okay, that's the key I want to give to you is when we go to do an engine issue or something like that, you know, diesel, sometimes there's special tools required to do a compression test that we may not own. Probably my guess is most of us don't own these special tools. So I want to show you how we can do a few things electronically with the tool, which I think you're going to find kind of interesting. I know it's diesel, but I did put one gas engine in here to kind of prove a point of how this works. I want to jump into an N14 Select Plus Cummins. There's nothing wrong with it. Just want to show you what we're going to do. I got a Duramax 6.6. All right, that's got actually right now it's got over 1 million miles on it. This is a vehicle we've been working on ever since this gentleman worked up here. He's a traveling sales guy, and it's a pretty interesting truck. It's got all original injectors and everything, and it runs great. There's nothing wrong with it. But I want to hit home a point of we can check the mechanical integrity of this engine without doing a bunch of work. I'm going to jump into a Ford Powerstroke 6.7. It's got a bunch of miles on it. Nothing wrong with it. Just want to show you how we're going to do a couple things. I got a case study of a P0016, which is a cam crank correlation code in one of these. All right, I'm going to show you how we're going to attack that. Then I got the old venerable 6.4 Powerstroke. it's got a misfire on cylinder number 4. And I'm going to show you how we're going to sort that out with a little bit of scan data and a little bit of picoscope. So with that said, we'll jump right in. So the first question is, what is an oscilloscope? I'm sure many of you out there don't know what an oscilloscope is or why you think maybe you should purchase one or acquire one or use one. Well, the simplest answer is it's a device that measures voltage over time. Okay, that's all we're doing. We're graphing voltage over time. And to get started, we got to talk about the equipment. And the equipment I like to use is Pico. And as of a few days ago, this is the kit I recommend for guys to get started out. They've got multiple different kits. It's a little bit of an investment, and it takes practice, and we're going to talk about that. But I think it's money well spent personally. This 4-channel kit, that's what I recommend. They make 2-channel kits. They make 8-channel kits. I think 4 channels is more than enough for what we want to do. You can go to picoauto.com and go there. If you've got any questions about what to buy, what not to buy, you can also email that to me. And the other tool I recommend is this pressure transducer. The WPS 500X is an excellent pressure transducer. Holds a 0 line like it's awesome. I mean, this thing is so accurate. And I like pressure transducers because they're calibrated to atmospheric pressure. I'm sure you guys know when you get a vacuum gauge from Harbor Freight or Sears or Snap-on or whoever, the 0 line's pretty wide because we don't know, what the atmospheric pressure is. So when you want to be accurate, and specifically when we're measuring inches of water, for instance, in an engine crankcase, like you're going to see me do later on today, I want to try to be pretty accurate. So something electronic that can zero to my atmospheric conditions where I'm working at, because I'm sure you guys agree. If I'm operating a shop in Denver, Colorado, or I'm operating in Florida, there's a little bit of atmospheric pressures difference there. It's not a lot, but it's a little bit. So. And they got some glow plug adapters and different spark plug adapters. Like I say, we're not going to do any in cylinder today. Today is basically relative compression and some crankcase testing. But I just want to show you that this transducer, it's unbelievable. You can put fuel in it, you can put air in it, you can put transmission fluid, oil, any type of pressure or suction. This thing can handle any liquid. It's very robust. So this is one of my mantras, right? Is the goal of diagnostics. All of us have goals in life, and my goal when I work on a vehicle, a truck, a boat, or whatever, is I want to figure out what's wrong without taking it apart. That's my goal. I don't always win, okay? Nobody bats 1,000, but that's my goal. I don't want to do a bunch of work or messing around and taking spark plugs out or glow plugs out and do a bunch of compression tests and break stuff off and be wrong. Because now I've got dollars involved, I've got time involved, and the customer may or may not approve the job. All right, so that's kind of a key. We're talking mechanical here. One thing I want to talk about is relative compression. All right, and I have a question, and I'm going to answer it for you. Is what is relative compression? Well, relative compression is a test that measures the comparison of an engine's cylinders in relation to each other. And what I mean by that is we're going to look at starter current here. And when I have starter current, I think you guys will agree that the starter is going to work the hardest on the compression stroke in a normal situation, okay? So when I talk about relative compression theory, I've got a couple of things here. We're going to graph this current. This is what's different than using a meter. So if I have a fluke meter or something like that, and I go around the battery cable and I roll the engine over, my meter is going to average, okay? I've got to graph this to really see. And I can also do a couple other things. I can test my engine's electrical system. I can test my starter integrity. I can find a bad brush in a starter. So I can actually do a couple other things in this test. And I can actually check ignition timing and fuel timing, which we'll get into here later on, which is pretty neat because I'm sure most of you guys that know that work on modern stuff, timing marks are a thing of the past. I mean, there's no more balancer with a tab with a 0 and a 12 and a line. Those days are long gone, okay? And sometimes we have to check ignition timing. And I'm going to show you how we do that. But my point is this is a relative test. We're testing it in relative to something else. And there's a few things we got to know when we talk relative. And a couple things I want to mention is if I have an engine that has a single camshaft, let's say it's an old 350 Chevy or 6.2 diesel or pretend whatever you want to pretend. I don't care. I got a V series engine, 4-cylinder, and it's got one cam in it. If that camshaft is off, whether it's advanced, retarded, or whatever, all of those cylinders are going to be affected equally, okay? But when I have an engine with multiple camshafts, whether, or a dual overhead cam, now I could have one cam off, it should only affect one side potentially. Sometimes on an intake cam, I can have an intake cam just slightly off, and I can actually have more compression than normal. When I have two cams, and the same thing with a bank-to-bank engine, I have a V6, a V8. If one side's off, the other side is going to breathe a little bit differently typically, and you'll see, sometimes you can see that in starter current. So that's kind of handy to know. I've got case studies. I'm sure if you guys have watched me before, you see me do case studies on Nissans and some other vehicles, and the timing wasn't correct, and you could see it on starter current, all right, which is pretty interesting. If you got misfires, for instance, on one bank, one of the things I like to do right out of the gate is do this relative compression cranking vacuum, which I'm not talking cranking vacuum today on diesel, but it's a very good test. Using a scope, and I can perform this test quick. It's non-intrusive. I'm taking a current clamp around a battery cable, all right, and I'm going to trigger off an event. Okay, we always trigger off a combustion event, such as a fuel injector of a diesel engine or a spark event of a gasoline engine. We don't trigger off gasoline fuel injectors because we never know when a gasoline fuel injector fires. Okay, and judging that, well, I'll show you here in a little bit. Judging that, we can tell when spark occurred in relation to TDC using starter current, because obviously when the piston's going up in the bore, the starter is working the hardest going up. I expect the starter current to peak, all right, at TDC. So I can see where my spark happened in relation to that and kind of get a rough idea. Is it exacto? No, but I can get a rough idea where spark occurred. So if I have a reluctor that has shifted, or some kind of ignition system problem where spark timing is affected or fuel injection time is affected, I can see it. Okay, and this is one of my first tests. When I get a vehicle in here that doesn't work right, believe me, once you get going, you can do this test. It's not going to take you 15 minutes. It's going to take you 15 minutes to, less than 15 minutes to dig the scope, hook it up, and do this test once you're proficient in it. And you'll be surprised what you can find with it, to be honest with you. So the tools I need a scope, I need a high amp current probe, I need an inductive or capacitance secondary probe if it's a gas engine. Okay, I know this is diesel, but I'm going to start out with a quickie gas engine just to prove a point. And then I need a voltage lead or a low amp clamp to access an ignition coil or a fuel injector on a diesel engine. And I'll show you how we do all that. And I may need a voltage lead, depending on what I'm working on, to grab a camshaft sensor or a crankshaft sensor. I'm going to show you, I've got a neat way to deal with a Duramax that I'm going to show you how I do this. So let's get going. Gas engine, I know it's a diesel class, but humor me for a second. I got an inductive plug wire probe here, all right, and I got a high amp current clamp. And what I'm going to do is there's a few prerequisites. Just like anything else, you want to do your testing, if possible, especially if it's acting up when it's warm, with an engine at operating temperature. The joke I use is when the alarm clock goes off at whatever time you get up in the morning, are you ready to go? I mean, when that alarm buzzes off, are you absolutely ready to operate? No, your eyes, whatever. You need a cup of coffee, you got to move around. I feel an engine is very similar to that. I don't expect that engine to be at peak performance as soon as I turn the key. Okay, so I like to do it on a warm engine if possible, and I disable the engine from starting. Most of us, I'm sure, on here are not dumb. We know how to make an engine not start. I'm sure you can figure out a fuse, a relay, disconnect a crank sensor. In some cases, I'll show you to make an engine not start. Okay, so use your imagination, figure out how it's not going to start. I got to have a good battery. I mean, if I got a 6-year-old battery and it's been overcharged and it's got a bunch of green snot hanging out of the battery cable because it's leaking, that's not going to that's not going to help me. Okay, I got to have stable cranking speed to do these tests. If I have a battery that's dead and the guy's been cranking on it because it doesn't start, I'm going to get erroneous readings. Okay, so that is a prerequisite. I got to have stable cranking speed. We're going to connect that high amp current clamp around a battery cable. Notice I said A. I don't care if it's ground. I don't care if it's hot, because if you know electrical theory, whatever leaves the battery has to come back. So if I go on the ground side, I go on that. If that's one staring me in the face, that's where I'm going. If the hot side's right there, that's where I'm going. I don't care. Okay, I'm not prejudiced when it comes to battery cables. I'm going to whatever one is the easiest. All right. So, and if I'm on this gas engine, when I'm starting out with, I'm going to grab number 1 spark plug wire. If it's got wires, if it doesn't have wires, I'm going to dig on a coil. I'm either going to get on the primary side or I can use my amp clamp. If it's a 2-wire ignition coil, I don't care. I can go right around any wire because whatever current's coming in has got to go back. All right. And all I got to do is either line up my arrow or I can invert the pattern, which I'm not going to talk about in today's session since we only got a couple hours, but you'll see what I mean. And like I say, some of these diesel engines, it's easier for me on a Duramax, for instance, on the older ones, to unplug the crank sensor. All right. On a Ford, if I'm doing a 6.4 or I'm doing a 6.7, I pull the high pressure pump fuse for the volume control and pressure control valves. I'll talk more about that. All right. Humor me, I got a gas engine here. I'm ready to do this test. I want to evaluate this Crusader 5.7 out of a Tierra. You see, I got my spark plug, my inductive spark plug probe on here. I've got my high amp clamp right here. That's the starter. Pretty self-explanatory. All right. There's an arrow on my amp clamp. You know, typically battery power flows from the positive back to the negative. So I have the arrow lined up so it's facing that way. Here's some tips I got for you. On your scope, I like on gas engines 1,000 amps per division. I like 2 seconds of time per division. You know, we do some training classes on this, and typically what I see is guys that just get started out doing this is they have way too short a time base. You know, they're at 50 milliseconds, 20 milliseconds. You know, if you think about an engine cranking, it's a slow event. You know, most engines are cranking 150 to 200 RPM typically. So if I've got a really, really short time base, I'm not going to see a whole lot. I'm going to get one line and you're going to be confused. Don't be afraid to put some time on the screen. Okay, I like 2 seconds. 5 seconds is fine too. If I'm a carbureted engine, all right, I got some leftover fuel in it. I can shut the fuel off, and you can crank the engine for 5 seconds. A lot of times the engine tries to start, you know, kind of whirls up and it tries to hit. But as long as I can get, you know, 5 to 8 seconds of stable cranking speeds, I let it go. I'll tell you another trick that I've started to use here on some of these older engines, since I work on anything from Model Ts to current model year, it seems like, is I actually flood the engine with a carburetor. I warm the engine up, and if I take the accelerator and I give it 5, 6 pumps. And that should quell the engine from starting. And that gives me usually 5 to 8 seconds to what I need to do without doing a bunch of screwing around trying to pinch off a fuel line, or, you know, because if I'm working on a 69 Camaro, there's not a fuel shut off. Okay. I'm working on a boat, I got a fuel shut off. But on gasoline engines, I like to see 35 amps peak to peak, and I'll talk about the in a second, minimum. All right. Diesel engines, I like to see typically 60 amps peak to peak. Depends on starter style, depends what kind of engine I'm working on. Okay. But that's typically what I like to see. And let's look at some known good here. Here's my Pico screen. Scope is kind of a simple premise. I know it seems a little complicated, but let's take it step by step here. So my vertical mass here, my vertical scale is my voltage. My horizontal scale is my time, voltage over time, and I'm graphing this. This is why the best meter in the world, digital meter, can't do any of this. You know, it's going to average it, and I can't see it. You know, using it this way, I can pick things out in specific cylinders typically. So here we go. You see up here, I got 5 seconds per division, right? My minimum is 2. I got 5 seconds per division, which means I've got 50 seconds of time here on the screen. All right, so I got almost a minute of time, and I roll this thing over. Right here's 10 seconds. Right there is probably about 2. I roll this thing over for about 8 seconds. And you can see my red is my spark, and the blue is my starter motor current. And what I like about Pico is the zoom feature. You'll see up here, I've got this little magnifying glass. I'm going to click on that, and I'm going to, what I call, blow it up. I can actually zoom in to a section just like this. And I can start to see my number ones here. I do have some interference, okay, but my high guys are number 1. But what I'm most concerned about right now is my starter current humps, okay? I got to ask myself a couple questions. Do they all look the same? And what's the peak-to-peak voltage? Okay, that's what I want to know. So I drop a couple horizontal cursors, and I grab my horizontal cursors, and Pico tells me, hey, Chris, you've got 57 amps peak-to-peak. And if I look at this pattern, it looks really, really good. I don't see, it looks like they're all hitting pretty close to that top line. So that tells me that all the cylinders in this gasoline engine have pretty much the same compression. I know it's not a gauge, okay, but I know that I don't have a cylinder that has a weak hole at this point. My peak to peak is 57 amps. The reason I like 35 amps as a minimum is, let's say I had a timing chain that jumped, or let's say my cylinders are completely washed out with fuel, or some reason that I don't have compression throughout the entire engine or a few cylinders. If that engine is turning over too easy, or there's less resistance to the starter motor, I'm going to have less peak-to-peak amperage. That's why I say 35 amps is kind of my minimum there. All right, so that's kind of important. So that's how I can tell, hey, if I have some amperage issues, that hey, I've got an issue maybe with a pair of cylinders or a cylinder, something like that. Okay, or it's out of time, something of that nature. But that's what I want to talk about. And then I'm going to just zoom in. I'm going to fire up my zoom again. I'm going to zoom in over 720 degrees of crank. All of us know that an engine, the crankshaft spins twice in the cycle. So 360 is one spin, 720 is two spins. So this is number one, okay? And this is number one. So between here and here is two spins of the crank or one cycle. And now I can look here and I can see 8 starter motor current humps. And then I can dump my firing order in. Okay, I know what Chevy small block firing order is for a normal rotation engine. It's 18436 So all I do is fill in the blanks. So for instance, if number 3 cylinder didn't have any compression, I wouldn't have much of a starter current hump there. Then I can infer just using starter motor current, hey, I need to investigate why number 3 isn't pulling its weight. Pretty handy. You know, I work on a lot of marine engines. Marine engines are wedged in there, some of these boats. I see guys taking 16 spark plugs out, checking compression on 2 engines. That's a lot of work. I got an engine that doesn't idle right or doesn't seam right, or maybe I got crankcase pressure issues. Okay, if I'm a diesel engine, since we're touting this as a diesel webinar, you know, if I have a piston that's maybe cracked or got a hole in it or something like that, I can maybe catch this here. Or if I got a modern diesel engine and I got a misfire code, or gas engine too, I got a misfire code to say P0302 cylinder 2 misfire. If I do this quickie test and I see cylinder 2 doesn't have much compression, is putting an injector in going to fix it? No. Is a can of sea foam going to do anything? No. Okay. So I have a mechanical issue. So there's probably nothing I'm going to bolt onto that engine that's going to fix it. I need to investigate the mechanical first. And again, this does not take a lot of time to do. Now, another feature of Pico I like to talk about is the phase rulers. This is one of the nicest features of this scope. And what I like about the phase rulers is it gives me a breakdown that my eyes, okay, this gives me a visual that I can actually break down each individual cylinder. Because I'll go back for a second. You know, if I look at this, I just pop these numbers in here. This is kind of still like a white screen. You know, you can't really differentiate. I mean, you can, but I'll show you with these phase rulers, I can really differentiate each cylinder, okay? And how I do this, just a quick run through, is I'm going to click this rulers box, all right? And this little rulers menu is going to pop up. And I'm going to click on phase rulers, turn those on, and 720 is already pre-selected. Every time on every scope, Pico I've used, 720 is always pre-selected, which is, I just want to make sure I'm on 720. And since I'm an 8-cylinder engine here, I'm going to select 8 partitions. And I click all this stuff, and this arrow appears right here in this corner. And what I do is I drag that arrow to my number 1 spark line, okay? And then I drag the other one. You see there's 2 arrows here. I drag the other one and I line it up to the next number 1 spark line. And you notice I got dark blue, light blue, dark blue, light blue. Now, don't you see at the transition point that kind of lines up those cylinders? And this is really handy, like when you have a cylinder that has no compression. As you'll see in a little bit, when I have a cylinder that doesn't have any compression, I may have a smaller starter current hump, or I may have a large or no starter current hump at all. And you're trying to figure out who's who. Well, when I go put this phase ruler setup in here, I know that, hey, number 4 cylinder, I don't have any starter current here. Something's up. Okay, I'm expecting to see that. So for new users or users that have little experience, I recommend you do this. And when we do this in our hands-on classes, this is one of the things we practice is using these phase rulers to your advantage. But I like this. This gives my eyes a nice visual to what I'm supposed to be seeing. And I did mention we can check spark timing here. All right. And I can use a couple of cursors on the left. All right. And they're right here in this box. And I can drag them with my mouse. I'm going to line one up at my spark line. And in this case, the timing is firing just a little bit retarded, 4 degrees retarded, which is normal for these marine engines. Okay. I know what you're thinking. Hey, Chris, you know, most engines fire at, 10 degrees, 12 degrees before top dead center. I don't disagree with you, okay? But I can tell you on these marine engines and many, many automotive engines, gasoline, that it's not uncommon to see spark timing just a shade retarded, especially during cranking sometimes. Sometimes they're advanced. It just depends on what the engineering wants. But I'm also hooking up, or excuse me, I'm going to grab another cursor since I've got one lined up exactly at my spark line, and I'm going to bring the other one, and I'm just going to kind of eye it up at the peak of the starter current. And then Pico automatically tells me with the rulers, it says, hey, Chris, I'm at 4.83 degrees. Now, the reason I know it's after top dead center is because my starter current hump is to the left or before my red ignition pulse. So anything that happens to the left is advanced or early. Anything that happens to the right is retarded or late. So I know at that starter current hump, when that thing draws the max amperage, that is the most compression. The piston is completely TDC before the piston dwells and moves over and then gets shoved back down. In this case, gets drugged back down because no combustion took place. But I know that that's TDC in that cylinder, okay? Is it degree wheel accurate? No. Am I saying throw your degree wheels and piston stops away for an engine builder? No. But if I'm diagnosing an engine in a vehicle, in a boat, in a backhoe, or whatever, this is something that I can use to tell, hey, is that reluctor close? You know, I got an engine that doesn't have any power, or it acts like it's got just dragging an anchor or something like that. I can use this to tell, hey, the spark timing is in a reasonable area. I've got a case study that I'm not going to do today, but I had a customer send me a jet ski engine this year, and the key shifted in the flywheel, and the spark is happening over here, almost in the valley, almost 45. I think it was 60 some degrees late. Okay, engine wouldn't start, and it was a rebuild engine. It's a 10 beer story, and we don't have enough beer here to talk, but basically what happened is they installed an engine in this boat. It ran for a few hours. The customer brought the boat back and says, hey, this thing doesn't start. So what does the technician do? He checks for sparks. He's got it. He checks for fuel. He's got it. He takes a fuel sample. It's not full of water or anything else. Okay. He shows a compression gauge in the cylinder, an old school Sears and Rubbish compression gauge, rolls the thing over. He's got 120 pounds. He's lost. He's got no idea what to do. He's like, wait a minute. I've got all the ingredients. Now, this is a modern engine. It's got no timing marks. Okay. So they're a Pico scope shop. And he called me. He says, hey, Chris, remember you're talking about checking ignition timing? And over the phone, I walked him through this test. He sent it to me. I said, hey, dude, I said, you got something going on with this, with your ignition timing. I said, where is that? He goes, well, there's magnets in a flywheel net. I said, what's there? Is it a keyway? Is it a pin or whatever? He goes, it's a key. I said, I bet you that key shifted. Sure enough, he took it apart. That key had sheared and the spark timing was off. The engine wouldn't hit a lick. And he found it with this test. This is a powerful test. So I always tell guys to do this. Okay, you should always do this test. It's very easy to do, and you get, like I say, it's not degree wheel accurate. But if my spark line's firing somewhere over here in left field, okay, I know that engine's got no chance of running, because if that spark or diesel injection, whatever, is happening 60 degrees retarded of TDC, it ain't gonna fire. With that said, it's all diesel from here on out. I gave you my gas. I'm not trying to do a bait and switch on you, but I just want to give you an idea what we can do with this tool. So let's start on with this N14. This is a Select Plus. It's a 97 International. There's not a thing wrong with it, okay? And let's just pretend that something might have been wrong with it. And all I'm going to do here is I'm just taking the starter, my amp clamp, and I'm just going to go around a battery cable. It's got a Delco 42 MT starter, kind of stares me somewhat in the face. I know a lot of these trucks, they've got multiple batteries. You don't know who's what. But chances are I can go to that Delco or Denso starter or whatever, and I can take my high amp current clamp and I go right around that starter. Okay. And like I said, we're mechanics. We can figure out how to make an engine not start. Okay. In this case, we unplugged the cam sensor. All right. Or crank sensor, I think, whatever it was. I can't remember what I unplugged, but I unplugged something, pulled a fuse, whatever. And I rolled this engine over. You can see I rolled it for about 12 seconds or so. And you can see I'm at 2 seconds of division. I'm putting time on the screen. This is a slow test. All right. And I don't necessarily care who's who here right away. I'm not going to mess around and try to get on an injector or do something else if I don't see an initial issue. And let me back that up. I zoom in using my zoom feature. All right. I'm gonna grab this. I'm gonna zoom in, and I just bring my cursors down, and you can see I've got a bunch of cycles here, and my minimum is 60 amp on diesel engines. I'm 82 amps peak to peak. Would you agree that all these peaks are pretty much all the same? if this N14 Select come in here and it had a misfire and it's shaking or whatever like that, a lot of times again, don't I need special tools to check compression on this? Don't I got to have some kind of apparatus? Don't I got to pull a valve cover off? This thing's got a jake brake in it. You got to take the jakes out of there. This is a lot of messing around to try to do a compression test. Would you agree? Even though I didn't put a gauge in it, I know one thing. I know that all these cylinders are the same. And I know, and I put this in my known good repertoire, my known good database. And that's the other thing about scoping I can't stress enough. So many oftentimes I see guys drag these scopes out and they wait till they have a job that's kicking their you know what. Well, if you don't know what good is, how do you know what bad is? Okay, you got to practice. Okay, it's like Allen Iverson. You got to practice. All right, if you ain't practicing, you ain't gonna get good. So you need to get comfortable with this stuff. You got to do it. You got to practice. You got to do it, and you'll get this. You'll start to get more comfortable. And you look at this, and I go, you know what? This engine does not have a compression problem. Now I can't rule out completely mechanical. I can't rule out a wiped cam per se. Okay, especially if it's an intake lobe. Depending on how bad it is. But I know I don't have a leak, okay? But I'm not finding a bad cam with a traditional compression gauge anyway. So who wants to screw around and spend 4 hours of time taking the jakes, all this stuff? Now you got to get gaskets for the jake. You got to run the rack. I mean, it's a lot of work to be wrong. If I can go around this battery cable, roll this engine over, I've got a pretty good idea. If this thing's got a dead miss and I get this, now I'm probably going to attack my fuel system. I don't have 15 minutes in it, do I, guys? Not at all. Okay. Very powerful test. Let's jump into Duramax. Specifically, we've got this 07 2500 HD. There's not a thing wrong with it. That's why I'm calling it relative compression research. And believe it or not, this is the truck I talked to you at the beginning of this program. And this truck now has over 1 million miles on it. All right, this guy bought it brand new. He's a salesman for a local oil distributor, and we've done all the maintenance since he moved to our area. We've been working on this truck since 200,000 miles. We put head gaskets on at 600,000. It blew a head gasket. It's been chipped up, okay, early on in its career, so it did have some performance modifications, which a lot of these LBZ trucks and so forth do, okay. But what I want to do is I want to pretend. I don't want to pretend. We're not Mr. Rogers just quite yet, but what I want to do is I want to go in here and I want to figure out if I can tell if this engine is healthy. It's got close to 1 million miles on it back here in the spring when we looked at this, and I want to figure out if this engine's good. Okay. Now, I know this is a scope kind of seminar, but I would be not honest if I told you that you shouldn't use some scan data kind of first. All right. And if you guys are familiar with Duramax Diesel, one of the things they have is balancing rates. And I know on the older engines, you can't look at them off idle, which this is one of them. Okay. I think the LMMs and the LMLs and all that, you can look at balancing rates, at more throttle ranges. But the old LB7s, LLYs, LBZs, these things are only good at idle. All right. But this has the original injectors in it. This is amazing. Okay. And GM says that everything is between, you shouldn't see anything more or less, plus or minus 4 millimeters cubed. And I see this, and I don't have anything close to 4. This truck runs perfect. I mean, it is unbelievable. There's not a noise in this engine. This guy takes such good care of this thing. But I don't have anything here that shows me anything to even want to do a relative compression test, to be honest with you. Because if I had a cylinder that had a cracked piston or low on compression or a bad injector, typically, especially if it's acting up and down, typically I'm going to see it here in balancing rates. But like I say, I wouldn't be honest with you if I didn't look at this first. I'm not saying you jump right to the scope. Again, I'm lazy. All right. I want to do the easiest things first. And if I can plug a scan tool in and check for codes and look for balancing rates, I'm doing that first before I'm putting a lab scope on the vehicle typically. Okay. But right out of the gate, what does this tell me about the health of this engine? Probably going to be good. Now, we use all data here in the shop. This is not an endorsement, it's just something, it's what we use. But this is basically what they want you to do a compression test. All right. I'm not going to tell you all this. You can read it later on. Like I say, the presentation is available for download. But they're basically telling me, hey, Chris, 300 PSI minimum. Okay, this is a published GM spec, 300 PSI minimum, and we don't want more than a 50 PSI difference. On a Duramax, and this particular vehicle, this 07 Classic, this is just about a 3-hour job if you're a flat rape technician. All right. So, and if you're around here in the salt land, how many of you guys have worked on Duramaxes that the glow plugs break off? Almost always, if the electrical wire with that little, what is it, 4 millimeter stud, those break off. Now you're buying nuts. Now you're putting glow plugs on if you don't break them off. All right, because then you got to dig out the Miller Krups tools and try to dig these things out to try to do a compression test. This compression test could turn into the biggest can of worms. And let's say it does have compression. Now what do? Now you charge a customer $1,000 plus or whatever to slam glow plugs and dig 2 of them out, and you're not even close to the situation. So how about we use Pico and use a relative compression test to figure out if this thing's got any issues. All right, it's not going to take me 2.9 hours. But if it's the first time I've done this, I got to do something. And this is my procedure on how I handle the Duramax. Basically, what I want to do is I want to acquire the camshaft signal. All right, I'm going to show you how we're going to do that. And we're going to get on the cam sensor signal. I can't get on the crankshaft sensor signal because the crank spins twice, okay, per revolution. I can't ID a single cylinder. I can ID a pair of cylinders, but I can't ID a single cylinder. I want the engine warm if possible, assuming it runs. Then I'm going to unplug the crank sensor. That's what I find on these older trucks is the easiest way to disable it from running. I don't like running these things out of fuel. I know, yes, you can probably pull the fuel line off the fuel filter or crimp the line in that, but I'm just not a fan of running these high pressure pumps out of fuel or injectors, especially something with this kind of money in it or miles on it. Because you know what happens when we try to do something and then all of a sudden we have another problem. Sometimes the customer doesn't understand that, because if he brings the thing in and it's running great and I'm trying to do a little bit of research here and all of a sudden we got an injector that's stuck or something, now I've got egg on my face potentially. So I'm not a fan of running these things out of fuel. Same procedure as my gas engine. All right, 2 seconds of screen minimum. I'm going to crank the engine 5 to 8 seconds. We're going to analyze. All right, and I'm not going to have 15 minutes in this, believe me. Crank sensor on a Duramax V8 is located right here. Most of these trucks are jacked up anyway, right? They've got the big tires and all that. If not, it's not a big deal. I can crawl under there and I can pop this thing out. It's not too difficult, okay? Here's a little wiring diagram for this particular LBZ truck, all right? My cam sensor is right here. And pin 1, the dark blue white, is the cam sensor signal. I did put the crank sensor signal in here because I got to figure out where the camshaft fires in relation to number 1 cylinder. All right. Now I'm going to tell you where it fires, so I'm going to cut right to the point. But the reason I want to go over this just for a little bit is I want to show you that I could work on that N14 Cummins, or I could work on a Detroit Diesel Series 60. Okay. We don't do a lot of typical big truck stuff here, but we do a few things. And I can figure out where number 1 fires in relation to a cam signal. So basically what I'm saying is get on a cam signal of anybody's engine, diesel, and get on an injector pattern. And we're talking electronic diesel here. We're not talking old 5.7, 6.2s, old school diesel. My base of my discussion is modern electronically controlled diesels. Okay, no 7.3 IDIs, none of that stuff. I can use the current, but I can't ID cylinders. And I know you'll go online, and yes, I see guys, zip tie knock sensors to the fuel injection rail and all that stuff. I've seen that. I haven't done that yet, but purpose of our discussion today is modern stuff, or pseudo modern. So I'm going to show you in this crank sensor because if sometimes I might want to get on that to see what the crank is in relation to the cam. But for our discussion right now, I'm going to get on number 1 injectors wire. These Duramax injectors are piezo injectors. There's 2 wires. If I'm using current, do I care what wire I get on? Not at all. Not at all. So I've got my amp clamp here, and this green is cylinder 1, and this green is cylinder 1 here. I input my Duramax firing order, 1278456 Okay, this, and I got my phase rulers deployed. This is why I started with that gas engine, so I can cut to the chase on some of this stuff. I got my phase rulers deployed. You can see that I can ID my cylinders where they're at. I know this is number 1. I know this is number 1. And the Duramax cam sensor, this has a 2 wide, 1 narrow design. 2 wide, 1 narrow. All right. And I can infer something here. Okay. And what I'm inferring is the number 1 cylinder fires directly after the second wide pulse. That's pretty interesting. So number 1 fires after the second wide pulse. I got that in my memory bank. I jot that down. When I go to do this, I don't need to do this anymore. Okay. So guess what? I'm going to use this crankshaft sensor signal, and I'm going to take my battery cable, or excuse me, my amp clamp around a battery cable, typically on the passenger side, because that's where the starter's at. Okay, and I'm gonna do that, and I'm gonna rotate. I'm gonna roll this in. I'm gonna unplug the crank sensor. I'm gonna roll it over, and this is what I'm gonna get. This is my starter motor current. This is my cam sensor. I unplug the crank sensor. Let's zoom in. All right, I zoom in without using cursors in that. What's my opinion, or what's your opinion of the starter motor current? Don't these starter motor current peaks look pretty good, pretty even? Okay. Do I necessarily have to dig out and grab the cam sensor if I have a starter motor current pattern that looks like this? No. The only time I need that cam sensor is if I want to ID who's who. Okay. So I'm not necessarily maybe jumping to the cam sensor right away and going to do this. I'm going to maybe just go down there and unplug the cam sensor, take my high amp current clamp, and roll this engine over and look. And in this case, this almost a 1,000,000-mile truck at this time, 125 amps peak to peak. Look at this. That is picture perfect on almost a 1,000,000-mile engine. That's why when I did the research when I was putting this class together, I'm like, man, this is awesome. I want to use this truck that's got almost 1,000,000 miles because I think it's interesting that I can prove my point, okay, that I can use this on something that's got no miles or a ton of miles. So let's take this a step further. Let's say I need to know the firing order, which I already kind of told you. And in this case, I'm using Process Pro, which is from AERA. Okay, you AERA members, you know, I suggest that you subscribe to this. If you don't, this engine specification software is unbelievable. So I'm just going to punch in LBZ Duramax 2007, and it tells me the firing order. And guess what? I'm going to put my firing order in. It's 12784563. And the reason I know this is number one is because my number one firing event would have my injector current would have taken place right here. Now with the crank sensor unplugged, obviously I don't have any electrical power to the injectors because this test, I don't want the engine to start. I want the engine to crank. I want to listen to it audibly. I want to listen to the cadence, just like a band. Okay, I want to listen to the cadence. Does it sound rhythmic? And what's my peak to peak? Okay, my peak to peak's $125-ish. There's where my number one would be because it's after the second wide pulse, and I could just plop my firing order in. So let's say number 8 was weak. I can see that right there. Would you agree? You see my step. I take the current, I unplug the crank. So basically, I'm going to cut to the point. I unplug the crank, a warm engine, unplug the crank sensor, take my high amp current clamp, go to the battery, roll it over. I roll it over. If everybody looks like this, do I give a poo of who's who? No, no. I'm only going to do this is if I want to ID something. So you can do this in under 15 minutes. Okay. So I just want to show you that, hey, I do it that way first typically, but I just want you to understand where I got, how I know where number one fires, what research I had to do on the engine to get that information, and then I can apply it. Okay. I just don't want this to act like it's coming out of the sky and it's just showing up here. I want to give you, you know, a relation or, you know, an idea of where this stuff comes from. And it's not that hard. Okay. It really, if I can do it, you can do it. Believe me. So that's how I deal with Duramax. Okay. Pretty interesting. I think you'll find that if you start to do this, you'll start to see stuff. You'll find it's a lot easier. You know, you guys that work on 45, 5,500 trucks, not the easiest thing to work on sometimes. You know, you're working on these pickup trucks, these newer LML trucks, LBZ, or excuse me, LML, LMM. You know, a lot more junk on there. Not fun. You got to take your inner fender wells out sometimes to get this. That's not a good day. And then brake glow plugs, like I said. Would you agree that I can do this really, really fast and figure out if I got a dead miss on number 6 or something, and I've got great starter motor current that is probably not an engine mechanical problem? Pretty good stuff. So let's keep going. I got Powerstroke 6.7. Okay, turns out pretty good engine in my opinion. Okay, but I got a couple research goals here. All right, got the same theory I'm going to do with the Duramax, but I got a tip here. We're going to grab the known camshaft crank pattern. Okay, I want to identify where number one is. You're starting to see my mantra here. You're starting to see my program. All right, we're going to scope it versus a starter motor. All right, we're going to capture some stuff for my database because again, I can't stress this enough. If I don't know what good is, How do I know what bad is? I showed you how to do it with, the old school way, or if you got to dig in and get on an injector current. But, all data, Mitchell, Identifix, all these people, they're not going to tell me where number one fires. It's just, I have yet to find any of that information. Very, very rarely. Okay. I could get the info. I could scope number one, like I said. But this is something that I hope you get out of this course, all right, today, because you're spending a couple hours of your time, is, believe it or not, Ford, since 1993, since the last version of the 7.3 IDI engine, all right, has published a coffee table book, all right? And these books were sent to, or given to dealer technicians when they went to Ford training, all right? And they are an absolute wealth of information. If this is all you get out of listening to me for 2 hours, it's a win. And I'm going to show you where to get these things for free. Okay. Anytime I hear the word free, I'm always excited. All right. And where you want to go is you want to go to this site right here, FordDoctorsDTS.com/coffee table books. All right. Or you can go to Ford Doctors DTS and you can click around. Now, what this site is, this is not a public site. All right. The place that link here is public. But what this is, these are Ford dealer technicians that communicate amongst themselves, okay? And you have to be a dealer technician to get in. If you apply to join, they ask you for a dealer P&A code, and that they won't let you in, okay? You either have to be a former technician or work in a dealer. They ask questions. I believe they call the dealership you claim you're working at, so don't try to join. They won't let you in, believe me, okay? But you go to this site, and there's all these books here, starting with this 93 truck, and you'll see 6-7 books, 6-4, the diesel engine and the transits is in there. They have all kinds of pictures of oil flow, coolant flow, how the turbo works, interesting stuff. And the reason I'm telling this is we're going to steal a page out of this book. And I do have a tip, and I didn't put this in this presentation. I probably should have. Maybe it's just me and my computer, because maybe I look up stuff that I shouldn't look up, if you know what I mean. But it will not download under Google Chrome. You have to. I'm a Chrome guy. Again, not a commercial. Just I use Google Chrome. But in Microsoft Edge, they download. So if you got Google Chrome, you go here and you click this thing. It's not going to come up in the corner. You know how these things come up in the corner and it says it's downloading. I don't know. Maybe it's got something in my computer. I've tried it on a couple others. I can't get it to go. But if you use Microsoft Edge, it goes. But go to this site, download all these books, because you know what? This site could disappear tomorrow. Okay. And this knowledge, this information, these books is just unbelievable. And I'm going to prove it to you here in about 2 minutes. This is the 6.7 Ford Powerstroke coffee table book, all right, that was given to dealer technicians, all right? And I've known about these books for quite some time. And when the 6.7 came out, I was really interested in this engine. So I read this book cover to cover, and I still utilize it. I still use it from time to time. And this is why. Because in this coffee table book, it gives me the information that I need to figure out where number one fires to do a relative compression test. I don't need to screw around and get on an injector. I don't have to screw around and do all this stuff because Ford gave it to me in this book. So I want to just show you where I got this stuff. Again, it's not like it just fell in my lap. Well, maybe it did, but this is where I got all this. And you can see, looking at this pattern, that this is a 60-2 reluctor, which we'll talk about in a second. Number one fires right here. And here's my cam signal. I know this might look a little confusing to look at, but I'm going to we're going to make it make sense here in a bit. And it gives me the degrees. It tells me the width of the degrees and the cam and the crank signal. This is good information. As a diagnostic technician, this is gold. Okay, this is Diag gold. I wish every manufacturer gave me this. Chrysler used to do this back in the old days with the DRB3 when you had the PEP module, you could scope an old 2.7 Chrysler or 3.5 or something like that. They gave you the crank and cam pattern. Sometimes Ford does, but this is nice. And we're going to get into this. We got a small, medium, and large tooth in the cam. And right here, I have a small cam tooth. I have a medium cam tooth and a large. It's like going to McDonald's. You want a small, medium, or large? Okay. And basically, what I know is number one cylinder fires immediately after, specifically, the large cam tooth. That's all I need to know. Number one cylinder fires after the large cam tooth. Kind of like my Duramax. Number one cylinder fires after the second large tooth. Remember the Duramax has one narrow, two wide, and it fires after the second wide pulse. This Ford, it's kind of nice. I like it when something like, okay, it's after the wide tooth, boom, that's when number one fires. I'm excited. The other thing I'm always interested in sync. And what I mean by sync is the camshaft to crankshaft relationship and or sync, okay? And I make a note here, and this is my -2 teeth section right here in this corner, and I make a note that this red spot from the end of the small tooth, okay, that there are 8 crankshaft teeth before this missing section on a known good engine. That's good to know. It's always good to have these sync points, all right, because we might end up using this later, all right. And I just blow this up to make it more sense, make more sense, I should say. And I got my small cam tooth here, and I just drop lines. And if I count, I'm not going to count to you, I'm not counting Dracula, but I got 8 teeth here between my missing section. So if I have a cam crank correlation problem, which you might see here coming up, this is an easy way to deal with this, okay? Probably not going to find it on compression, more than likely, all right? So what do I know out of all this, okay? I can infer now where number one cylinder fires, which is great, okay? And I know where a good cam crank synchronization is. I know it's 8 teeth before the small tooth, or right or immediately after the small tooth, okay? To hit home my point, this is an engine that I had apart not too long ago, okay? And you can kind of see the small, medium, and large teeth, all right? Now, this cam rotates counterclockwise, all right? The crankshaft turns clockwise. This thing rotates counterclockwise, all right, because it's a gear to gear. And the cam sensor's in the front cover, and you can see small, medium, and large as that thing goes around. I have the traditional 60-2 crankshaft reluctor. Now, I can't see the teeth in this magnetic encoder ring, but believe me, there's room for 60 teeth, and there's only 58 of them. So, hey, we've seen these things fail in the Eco Diesel, have we not? A Chrysler, we've changed quite a few of these. They come in, they don't start. I'm sure if you guys have worked on some cars, you've seen this issue. All right, the scope is the best way to go after that. You won't have a crank signal, but this thing peels off on those Eco Diesels, all right, and you got to pull the transsliption to get to this. Not an easy job, all right. So it's not like an LS engine or something that you've got a big crank trigger in the oil pan, for instance, or some Ford gas engines that are external. This thing is bolts to the end of the crankshaft, all right? And there's an alignment pin in here, okay? Not picking on R&R techs, but, guys, we love impacts and stuff. They hammer this stuff in here. Maybe we could do some damage to this. Maybe we don't line this pin up. Maybe this thing gets off. Now I got problems, okay? Now that I know what I'm looking for, let's put it to work, okay? So let me get a cam crank waveform. So I pull up this wiring diagram, and the crank sensor here is this yellow-orange wire. That's what I'm interested in, all right? Right to my PCM, and my cam sensor is going to be my white-green, all right? Pin 32 and pin 33. They're right next to each other. Real handy. And I pull up a connector diagram from AllData, and it basically kind of tells me the same thing. Hey, Chris, 32 and 33, white-green, yellow-orange, those are my two guys. And here's basically, and it is in the connector. It's C1232E. For you Ford technicians out there, you love these new PCMs. I think they're built by Continental. Don't quote me on that. But you have C1232B for body, C1232E for engine, which is typically the middle connector, and you got C1232T for transmission. So basically, my long-winded point is the middle connector is going to my engine wiring. If I'm a Ford drivability tech, that's the connector I'm interested in. And I take a little small screwdriver. We're not hacking the customer's car up, or truck, and we're just going to peel back these little tabbies here, and I'm going to cut the tape at the bottom because there's a little bit of tape roundup on that, okay? And we're going to pop this guy off, and I'm going to back probe those two wires, okay? Not that hard. It might take you 5 minutes to do this. One nice thing about these Fords, I can get right up here next to this battery, and this connector stares me in the face. I'm not in a lot of messing around. I can get right in here, and this is where I'm going to get this information on this truck. I fire this thing up. Don't I see a small, medium, and large? It's like the drive-through at McDonald's, small, medium, large, right there. Here's my 60-2. I can see that the crank is spun here, 1.5 times-ish? And this, I don't know where number one is yet. I mean, I can figure it out. Okay, it's right around this area. I'm interested in cam crank synchronization at this point. Remember with the Ford coffee table book that I was able to infer. I was able to infer that there are 8 teeth between the missing section and the trailing edge going down of the small camshaft tube. So I drop a couple cursors in here. Pico's got math channels. I'm not talking about this right now. We don't have enough time to go into all this, but I got a couple of math channels here, and I'm going to pop this in, and Pico tells me, hey, Chris, there's 8 teeth. Now, I could count it. I could zoom in, all right? And I'm not going to count this for you, but I know that there's 8 teeth, 1, 2, 3, 4, 5, 6, 7, 8, right here. The trailing edge of my small tooth of my cam sensor happens. This is known good synchronization. This truck's got 300-some thousand miles on it. It's known good, okay? Ford tells me that's what it should be. That's what I got. It's always good to back up. I'm not saying Ford's liars. That's not what I'm saying, okay? But it's always good to do this because you know what? If I read something like this and I've never done it before, you know, and all of a sudden I get this truck that's got a problem, I'm kind of fumbling around, you know, you don't really know. Or then maybe you're calling a friend, say, hey, is that what this is supposed to be? But if you do this, if you practice this on a truck, you know, when one of these comes in, it's going to be second nature. Like, you know what? I've done these. I've looked at these. Here's a known good in my database. Real handy, especially when I got this job. Okay. This job happens to be a 2013 F550. It sets a P0016, which is a cam crank correlation code. Truck runs great. Okay. But it's got this code that won't go away. You can clear it 150 times. As soon as you start up, bam. I mean, you can count to 5, bam, this code's right there. Okay. And this came from a fleet shop, and they do their own maintenance, and it was brought to us because they want us to look at this thing. And the point I want to make is we're going to see what if this cam is out of sync with the crankshaft. And that's what a 0016 means. And if I go to the Ford website, which I have here, and I punch in P0016, they basically tell me, hey, Chris, this DTC sets when the gap on the crankshaft sensor wheel is greater than 6 degrees from the expected location. Now, I'm not a math scholar, but I have 60 teeth, or room for 60 teeth on my crankshaft reluctor wheel. If I divide that by 360, that's 6. So basically, what does that mean? That means if that cam crank synchronization is 1 tooth off, I got this code. Okay, I got this code. Now, it could be off at the crankshaft. It could be off, you know, on the cam crank timing. But that's what that code means. That code means that I see at least 1 tooth out of sync. That's the bottom line. I'm not going to read all this to you. If you follow this in the Ford scan, if you use Ford a diagnostic process on this, it can be a huge wild goose chase. Okay, it's going to be a big ohm-meter exercise. It's going to tell you to check the gap between the crank sensor and the wheel. It's going to tell you to do the cam sensor. They're going to have you put sensors in it, then they're going to have you put a PCM in it, and they're going to tell you good luck. Okay, that's basically what they're going to tell you. All right. But I don't want to jam anything in this thing. I want to know what's going on. Okay, so we're going to practice what I just showed you. I get on those same pins, 32 and 33 of this truck. I fire it up. All right, you don't even have to run. I can do this test cranking. It just happens to run. Okay, so let's say it's way off and it won't start. I can get on here and check the synchronization, no problem. So I get on here. I get on these 2 wires. I roll this thing over. It fires up. I maybe only let it run for 5-6 seconds. I got what I need. Let's dig in. So I zoom into that same area, my missing tooth. This is my trailing edge of my small tooth. I shade it in yellow to see, and I'm sure you guys can see, you can count that I've got 9.5 teeth. It's supposed to be 8. I'm a 1.5 tooth off, which basically means like 6, you know, it's what, 9 degrees off. So this is a huge deal. This is why this code sets. You know, I have a synchronization issue here. It's not, this thing should be over here. It's not. What's Ford tell me? Ford says, hey, Chris, this thing sets in 2 revolutions. That's why as soon as you clear the code, it came right back. As soon as it saw 2 revolutions, it sees that cam crank synchronization out, bam, the trade-in light comes on. I can make an inferral here, an inferral. And I can infer that this is to the right. This crank pattern is to the right of where it's supposed to be. So I know this thing is retarded. Okay, this thing's retarded about 9 degrees. The Ford published procedure would have been, I mean, it would have been horrible. We would have had cam crank sensors in, a PCM like I just told you. But you know what? I think the next step here is let's pull the front cover. We pull the front cover, and I look at this, and yeah, you can see the marks line up. I mean, that's a high pressure pump there, and I can see these 2 marks line up. But you know what? Marks aren't what the computer's looking for. Those marks are just for our eyes. Computer ain't looking at marks. He's looking at that crankshaft reluctor bolted to the back of the sandwich between the flywheel and the crank, and he's looking at this relationship between this small tooth, is he not? And I will tell you, if you go back, I'm not going to flip all the way back. I probably should have put this in there. I apologize. But if you go back to the engine that was good, you'll notice that this bolt right here is supposed to be at the 12 o'clock position. This thing moved. If you guys are aware of this, I'm sure some of you big time engine builders are, this crankshaft gear is a press fit. And I know some of the engine builders that are welding these things. Well, what has happened is this press fit crank gear has moved on this crankshaft. It moved on this crank, which is a freaking no-go. Now, this is a problem. And if I tear the front cover up, here's my long-winded point. If you think the timing's off, if you pull the cover and you go to your boss and say, hey, boss, these marks line up, you're going to throw your hands up. You're going to go, hey, boss, it's lined up. Now, the next thing you're probably going to do is you're going to probably pull the transmission, all right? And you're going to replace an encoder ring. You're going to put it all back together, start up. You got this 0016 you can't get rid of, But the scope told us, it didn't tell us necessarily look at the front, but we know that these issues are common where some of these trucks or these things move. But the scope told me what the computer was telling. That's why it's not intermittent, okay? Sometimes, basically, let's say that thing only moved around 6 degrees, one tooth. Well, then maybe one day, maybe some of the time it passes, some of the time it fails. It's borderline. I know what it's supposed to be. I've got known good ones in my database. That's why when we plug this in, this code's legit. This is legit code. And since I've had these apart before, I know this bolt should right here be at 12 o'clock, not 1 o'clock, okay? This thing is retarded. It's moved. And our friends at AERA have a technical bulletin on this, all right? I'm not going to read you the bulletin, but basically what it says, hey, Mr. and Mrs. Engine Builder, do not remove this gear. We don't recommend it because it's hard to do what? The precise location. There's a jig, I'm sure, at the factory to fix this. Now, I'll tell you what I did, all right? We heated it up. We pulled it off. We heated it up, and I put it right back on, and we welded it. And you know what? I could verify it was right before it left the shop because I could slide the front cover just back on with one bolt, put the cam sensor, roll this thing over. And that's what we did. We didn't pull the engine out of the vehicle. We just fixed the gear. Okay. We pulled it off. I heated it up in an oven, slid it back on, and we got it where it's supposed to be. Okay. And then once we verified it was correct, then we welded it. Okay. That's how we fix this vehicle. All right. Like I say, I know a lot of the engine builders weld them, but I just want to show you that I can use this scope. I know it's not starter current relative compression, but relative compression, this thing was within my 60 amps. Let's jump back into relative compression. I got this 2012 F350. It's got 330-some thousand miles on it. There's nothing wrong with it, okay? I just want to do my relative compression. Let's pretend there's something wrong with it potentially, okay? Same story. I go to all data. They tell me, hey, Chris, do a compression check on this 6.7. It's a 3-hour job. I don't know about you. I am not excited to spend 3 hours trying to do a compression test. Yes, I know if you're a Ford factory scan tool user, they have the relative compression test in the IDS or the FDRS if it's a 2020 truck and up. That's a phenomenal test. But I've had some instances where there's a cam crank synchronization issue, for instance. Okay, that truck I just showed you would not run the relative compression test in the scanner because the computer says, hey, I see a cam crank synchronization issue. You know what? Chuck you, Farley, it's not happening. We're not giving it to you because we can't tell where number one is. So this is what's going on, okay? I've got 3.0 hours. I ain't spending that. I got a 6.7. We got to do the same thing. We got to verify our batteries are in good shape and sufficiently charged, okay? I connect my high amp probe to the positive battery cable. Now, these are kind of confusing a little bit. I go to the passenger side battery, okay, because that's the battery cable that goes to the starter. If I go to the cable that goes from the left battery that goes across the radiator support, I may not get all, in fact, I know I'm not going to get all the current, okay? So I got to be specific on where I put my current clamp on this diesel, all right? I got to be at the battery cable going down towards the starter. I'm going to back probe the cam sensor, all right? Remember, I've got the coffee table book that already told me where number one fires, okay? And I don't want this engine to start, okay? And I find in the easiest way on these Fords or anything with a CP4 pump basic or this pump setup is I can pull this fuse, all right? And on these trucks, it's fuse F37. And just a quick thing on how this works. The volume control valve is normally closed, okay? And the computer in that high pressure pump has to open the volume control valve to let fuel in to build high pressure. So when that fuse is pulled, that volume control valve is shut. There's no high pressure fuel that's going to be built inside that high pressure system. The engine is a crank no start. So it takes me 2.5 seconds, maybe a little longer than that. I'm kind of exaggerating, but it's going to take me maybe 20 seconds to pop that off. I go to F37. I take a pair of needle nose or the fuse puller tool. I pull the fuse holder or pull the fuse. Sorry, and I got this engine ready to do this. Okay, so it doesn't take me time. I set my scope up for some time. I put 5 seconds per division on it. It's a diesel engine. I like 2,000 volts per division because diesel is going to draw more. I can get away with 1,000, but I like 2,000. I do want to mention that. All right. And I got my cam sensor channel on 10 volts because this is a 5-volt reference. I'm going to crank this engine for 6 to 10 seconds, 5 to 8 seconds, whatever. Okay. Same procedure. All right, here's my fuse F37. This is right in the owner's manual, or it's on All Data, or whatever your favorite information source is. It tells me, hey, Chris, this runs a fuel pressure valve and a volume control valve. And just to back up what I was saying, here's the fuse right here. And you can see that it's the feed and the computer ground side controls. Again, this is not a high pressure diesel class. I'm just trying to show you how I'm getting this not to run to do this test. F37, that's right here. And here's a picture in this truck. That's the fuse I'm after, right by the brake booster. It's all the way to the back. Pop her out. I'm back probing. It's my C1232E for engine, the middle connector. I'm getting on the white green pin 32. So I'm back probing that. But you know what? I don't have to do that. Remember, I don't have to do that. The only reason I got to do that is if I want to figure out who's who. There's no reason I couldn't take my current clamp right here. Okay, this is my hot side. Yes, I know the battery looks like poo-poo, but I go right in here. And I don't necessarily care about doing that because if all these are the same, okay, and for instance, if I'm going after a single cylinder misfire, and I put my amp clamp around here, and they all draw the same current, it's probably not a compression problem. Okay, I'm just doing this if I want to know who number one is. So I practice what I preach. Let's roll this thing over. 5 seconds of vision. There's my cam sensor. There's my starter current. We're going to zoom in. I zoom in. Would you say it looks pretty good? I zoom in more. Looks pretty good. I don't see any low guys here. Again, there's nothing wrong with this truck. Do I necessarily care who number one is at this point? No, not at all. Remember what I said, 65 amps peak to peak? I'm at 72 basically, all right? 72 amps peak to peak. That's what I expect. That's what I typically see on these modern diesel engines, okay? There's nothing here that strikes my eye as, oh my God, okay? Let's bring the cam sensor in. I want to know who's who, okay? I bring my cam sensor in. And remember, number one is after the large two, small, medium, large, okay? And it's just a little reminder, I go back to my coffee table book. My coffee table book says, Chris, number one fires right here. So let's go back to my pattern. Here's a starter current hump. I drug a vertical cursor right to that starter current hump. Would you agree that it's immediately after that large hump? That's number one cylinder. I go right here to the next one. I should have 8, it's a V8 engine, okay? I should have 8 current humps here. I put my little yellow highlights in there to kind of accentuate what I'm talking about, all right? That's my number one. That's my number one. Right here, in between these two yellow guys, is 720 degrees of crank rotation. I zoom in more, okay? Now I've got a really, really good hit where this is at, okay? Really nice. I go to my phase rulers because it's easier on my eyes. I showed you how to do this a little while ago. I turn them on, 8 partitions, and I drag these into position, and I line those up with my number ones. Number one here, number one here. All right. Would you agree that I have a peakish right about where I'm supposed to have it? I don't know the firing order. Today's my first day on the job, okay? It happens to be the real popular Ford firing order, 137265548, okay? 351 Windsor, 460, 46s, all that. This is a pretty standard firing order these days, okay, for a Ford. But I use Process Pro to get that just to make sure, or my service information system. And all I got to do is pop my firing order in, okay? I now know who's who. I now know who's who. How easy was that? It didn't take very long. The first couple times you do this, it's going to take a little bit. It's going to be a little cumbersome. But the more you do this, it's like riding a bike. You'll start doing these things. Sometimes the scan tool can't help me. Just like I told you on that P0016 truck. IDS won't do a cam crank. If cam crank is off, the misfire monitor can be shut down, and relative compression in the tool may not work. Okay. I don't want to spend 3 hours doing this. Would you agree that this takes way less than 15 minutes? And I can verify if I've got some kind of issue, mechanical compression issue in my engine? Absolutely. Absolutely. Okay. This is a known good pattern on this truck. Let's jump into broke. Okay. I've got my favorite truck here. It's an O.A.E.V.T F350 with a 6.4. All right. Max 4.7. Not a good engine. All right. And it's good for repair shops. Okay. But they had a lot of issues in it. Okay. It's got almost 222,000 miles on it. This thing's got a misfire number 4 cylinder. All right. And here's the bottom line. This truck was another shop. They jammed an injector in it. And then the shop told them, it's like, you know what? It's got to be something with the engine. We don't really do diesel work. You know, it's funny when you talk to these shops, you know, they do diesel work if they can get it fixed, but all of a sudden they do a little bit of work on it and it doesn't fix the problem. All of a sudden they don't work on diesels, you know. So that's what this guy was told. But he brought it in here because he wants a second opinion. Okay. And we want to give him a second opinion here at Lakeland Auto and not spend a bunch of time on this because the guy, we don't know if he's going to fix the truck. So you know what my goal is? My goal is I want to back up. He was told that he thought the engine was junk. The previous shop did not have the compression test adapter to go into that cylinder, verify it had no compression. Okay. So we want to figure this out. Now we're going to use the IDS. We can do a couple things here. All right. And for you old school diesel mechanics out here on a misfire engine, you know, we got a heat gun. You know, you could stick a heat gun at the manifold. We could use water. We could use a spray bottle. I could crack open an injector line on old school diesel. On this 6.4, it's common rail. If I crack open a line, I'm sure you've read all those stickers. You're going to die and fuel's going to spray everywhere. But if I would happen to do that, it's just the engine's going to quit running because I lose all my high pressure. Okay. Plus it's dangerous. You shouldn't do that. And the 6.4, where are these injector lines? Under the valve cover. Can't see them. I got to lift the cab or take the turbo off to get the bed. It's not going to happen. If I swap injectors between cylinders, not an easy job on a 6.4. Got to get the valve cover off. It's a freaking half a day. You know what? Okay. None of these sound really enticing to me to do. Okay. This seems like a lot of work. All right. And the computer's already telling me it's number 4 that's missing. Okay. So the computer has an idea. We're going to try to back that up. I can use scan tool, relative compression, power balance, injector cutouts. Okay. I could use the heat gun, like I said, or I can use an oscilloscope. All right. I'm going to use Pico here in a second. One thing I want to tell you, this is not a scan tool class, but one thing I'm interested in before we just go out and put the scope on it is I want to look at fuel trims. And kind of like the balancing rates on the Duramax, Ford, International, whatever you want to call it, they've got some fuel trim numbers. And all these modern engines have fuel trim numbers nowadays. All right. And a negative numbers means it's pulling fuel to slow the crank down. And a positive number means it's dumping a little bit more fuel to try to speed the crank up. Because the computer's looking at the crank sensor and it knows what's going on. It knows that the crank's got to speed up or it knows it's got to slow down. So let's take a look at this truck. All right. It's got a it's got a cylinder 4 misfire contribution code. And I see a couple things that catch my eye. Okay. And I just drew these numbers in bigger so you could see them. Okay. This is cylinders 1, 2, 3, 4, 5, 6, 7, and 8. All right. Now remember, 4 is our guy. 4 is our guy. All right. But I see a lot of techs look at this and they infer that I've got 3 cylinders that have trouble. All right. And there's a reason I'm spending just a little bit of time on this. Okay. And you look at this, you're saying, hey, Chris, cylinder number 3, it's pulling 17. I go to cylinder 4, who I got a code for. I don't have a code for 3. I don't have a code for 5, but it's adding 17. Okay. If I got a misfiring cylinder, I can see where the computer's going to try to add fuel to try to speed it up. So I got to ask myself a question. And it's a good practice before I use fuel trims, you know, or misfire counters to see if there's some kind of correlation between these. Are these things companion? Are they adjacent? Are they in the firing order? Are they sequential? That's what I want to know. Okay. I want to know, is there a relationship between these cylinders? Okay. And it's not uncommon for the crank to slow down and speed up, especially on a misfire. Okay. Because that's what it's looking for. The crankshaft sees the crank be normal. All of a sudden it sees it drop and come up. It says, hey, number 4, you're not doing anything, dude. Okay. Now, for those of you that aren't Ford International savvy, you know, they're similar to a Duramax. You know, number 1's over here on the right bank. And so the odds are on the right side. The evens are on the left side. Okay. And the firing order is 1, 2, 7, 3, 4, 5, 6, 8. All right. Who's going to remember that? Not me. All right. So let's go back. So I asked myself, the firing order is 1, 2, 7, 3, 4, 5, 6, 8. Now this thing's pulling 17 at cylinder 3. Now I'm trying to think that. Let me just explain, or let me just make a comment. Assuming we know number 4 is our guy because that's what the computer says, which is probably right. if number 4 has maybe like a mechanical problem, like it's got no compression, would you agree that maybe since when the piston's going up, that number 3 cylinder the crankshaft could speed up a little bit over number 3 because the next cylinder in line it doesn't have any compression? Yeah, yeah, okay. And coming off, number 5 is afterwards. Okay, we know 4 is adding the most, but even 5 it's adding about 10. Okay, so it could be a weak cylinder, or B, it could be just continuing to try to get that crankshaft back up to normal speed. I don't know if that's 100%, but it's believable. But I see some technicians, well, they'll grab this, right? Because the rest of these are close to zero. See, that one's 1 0, 2's 3. They're pretty much single digits. Okay, so a lot of techs will look at this and, oh, dude, you got 3 bad injectors. So what do you want to do? They go to the service manager and say, oh, this truck needs a set of injectors. Look at this. He's got 3 in their junk. It's got 222,000 miles on it. It's whooped out. It's this. It's chipped up. It's the whole smash. Okay. Don't fall into that rabbit hole. Don't go down it, because if you sell a guy an injector, which is not a cheap deal, all right, depending on part of the country, this could be a $3,000, $5,000, $6,000 job, depending on what's going on, okay, and what kind of injectors you put in it. And if my point is, if you jam 8 injectors in this thing, okay, and you start up and it's still got the quivers, that's pretty hard to explain to the customer. Pretty hard for that customer to want to pay that bill. When you hand in that bill and say, oh, by the way, you got 2 problems. We found these injectors. They were bad because the fuel trims are crappy, and now we got the injectors in it, and now you got a bad piston. Customers don't want to hear that. They don't want to hear that. Believe me. So don't interpret this wrong. That's why I'm spending just a little bit of time in here, because I've seen this happen. Okay. And basically, this is my explanation. We don't have 3 down cylinders here. Or before we make that determination, we got to check the mechanical integrity of this engine. Okay. And we're going to do our relative compression test. Okay. And I couldn't do it with the IDS. I'm not sure why. It just kept failing. Now, this thing's chipped up. Okay. So who knows? When people start, and that's probably why it's got problems, because it's got performance modification. I'm not here to bash all performance modifications, but when you put stuff on the edge, when you live on the edge, you have more chances for problems. Okay. So that's what I believe sets this ECM, this contribution code. This computer's looking at that. It sees this thing. It tries to slow it down ahead of it. It tries to speed it up after. So it says, look, I see there's an issue here. Okay. I know there's an issue here. It's number 4. Okay. That's what I'm thinking. Now, this is not this truck, but Ford has a lovely power balance test. Okay. Because this thing wouldn't run the power balance test. All right. And this is why I'm using this as a case study for you guys, because sometimes I've got Ford factory stuff. I love the IDS. Easily my favorite scan tool, and easily the cheapest to own. If you're doing any type of Ford work, and I'm not a Ford salesman, I'm not related to Henry Ford or anybody. Okay. But if you're doing a fair amount of Ford work, you need to own this scan tool. It's all the reflashes are free. If you guys are doing GM and Chrysler, there's $40, $45 a VIN token. This truck makes you look like, this scan tool makes you look like a genius. With the service bulletins and SSMs, the special service messages, if you're doing any fair amount of work, you need to own this tool. Okay, it's an excellent tool. Again, I'm not compensated. It's not a commercial. I just really like this. But the point I want to make here is kind of back up what I was saying about that contribution. You look at this on this Ford truck. I've got this happens to be a 2.7 EcoBoost, and you can see number 5 is the lowest guy. But would you agree that the crankshaft is also kind of slowing down here, maybe in front of 2 a little bit? Okay, and then it speeds back up. There's nothing wrong with 2. There's nothing wrong with 3. Okay, 5's our guy. But if you looked at that graph, it would kind of make you infer, like, oh my God, this thing might have 3 weak. It's got 1 really bad cylinder. Maybe it's got 2 weak cylinders. It's not the case. Okay, so I tried the relative compression test. I tried the misfire monitor. It didn't work. Like I say, I'm guessing it's because of modifications. I don't know that. Okay. So first thing I'm going to do is I'm going to listen to the cranking cadence. We're talking about Pico. We're talking about scoping here, but don't get ahead of yourself. All right. And I listen to the cranking cadence. All right. And I'm not Jones from Police Academy. I'm not going to imitate any noises for you, but I rolled this thing over and Helen Keller could figure out that there's something wrong. Okay. This thing had an audible cranking cadence issue. Okay, so I'm going to pull a wiring diagram. I'm going to get on this cranking cam. I'm going to show you how we're going to do this. All right, and I got known good in my database. I'm not going to go through this all to you again. You've already seen me do this twice, but you get the idea. Number one fires right here in relation to this cam sensor. This just has an AC 2-wire cam sensor on these 6.0 and 6.4 engines, okay? And I have this noted in my notes where this is, that number one, okay, fires approximately 43 teeth right here before the cam pulse. I know that's a lot to take in, but that's where I'm at, okay? And I put my firing order in, all right, because right here I'm on an injector current. And I'm going to show you why we're doing this in a minute. Okay, but I add in my firing order. I use my phase rulers. You see me do this, it seems like, for 3 days now. I'm sure you get the point. All right, I can tell who's who here in my firing order. I'm not looking at starter current yet. Okay, number one firing event is 43 teeth. All right, I got that in my memory banks. So now that I've got a known capture, let's go to my broken truck, which happens to be this truck here. Okay, if I don't have a known good capture, there are a few places I can get known good captures. All right. In my opinion, if you got a Pico scope, you should start with the Pico library. Okay. We're not going to talk much about it today. We don't have a lot of time for it. But if you own Pico scope, all right, and get the software, you can register and you can get on the library. And there's folks like myself and others that put known good patterns up there for you. Okay. The best way is get it yourself. Okay. Get it yourself. But we got diag.net, Identifix, Facebook group, IETN, the whole smash. Okay. You can, or a buddy or something like that, you know. But again, the best place is your own. Okay, that's where you should go. You should get it with your equipment. So I look at this wiring diagram. I'm going to get on the crank sensor, get on the cam sensor, and I'm going to get on fuel injector number one. Okay, it's 2 wires. I'm using a current clamp. Do I care what wire I'm getting on? Not at all. Don't care. I don't care if it's yellow, blue, yellow, green, blue. Who cares? As long as I'm on one of those, I'm looking at the current. That's all I care. Okay, and many trucks, these Fords, I've pulled a lot of cabs, okay? And they've got the C139. I love this. It's right on top of the battery, okay? This is where I can jump the starter because a lot of times we need 2 people, okay? But I can do this test by myself, all right? And this is the connector right here. I'm sure you guys, if you've worked on these trucks, you'll see this connector. It's got it's a one terminal connector. It's right by the battery cable right there. I unplug it and I'm just going to use a jumper wire, okay? And I'm going to jump this thing because I don't want the engine to start necessarily. And I want to see what's going on. Okay. And I jump this truck. All right. And that's one good thing about AC sensors. AC sensors, I don't have to put power to them to make them work, you know, so I don't have to worry about that. And I've got my amp clamp around my battery cable. I'm sorry, I forgot to mention that. I've got my starter motor clamp around my hot 12-volt positive battery cable going to the starter. Okay. And I see something already. Blues my starter motor current, reds my cam, blues my crank. Okay. Would you agree that I got some kind of repeatable issue going on here? Do I need to bring my cursors down? I could, but I've got a repeatable dropout. Okay. In my starter motor, and you could hear this. Like I said, Helen Keller would have got this, that there's a mechanical problem here. That's why it was so crazy that they put an injector in. But, you know, we get so conditioned sometimes as users and as technicians. You know, vehicles start right up. You know, this isn't a 1961, you know, Chevy truck or something with the carburetor's out of gas. We got to crank it. We got to pump it. Okay. This thing, these modern engines, bam, they start right up. So a lot of times you don't hear a cranking cadence anomaly because the engine starts too quick. That's why I say slow it down a little bit, disable, and just listen to it. If you crank this thing over and it's got a cranking cadence anomaly, we're not putting injectors in it more than likely, okay? Unless the injector pushed out of the head, okay? It's not the injector, which we know the 6.7 Powerstrokes, the early ones did that. They broke the clamps and broke the bolts out of the valve cover. I'm sure you guys have seen that, okay? So you look into this, and I see I've got a hole here, okay? And it repeats. There's my cam sensor signal, all right? I can see that. Repeats. I can also see it in my crankshaft sensor signal. One good thing about AC sensors, I don't want to get too deep in the weeds here, is you see how this signal right here kind of got bunched up and it kind of grew a little bit? Well, AC sensors or VR type sensors, when the speed increases, the amplitude increases. So I could put blinders on that blue pattern, and when I see my green pattern kind of grow and I know the crankshaft speed sped up. And look right after it. You see it kind of slowed down. because guess what? That crankshaft sped up because number 4 doesn't have any compression. We don't know why yet, but number 4 doesn't have any compression. And then the crankshaft got a nice wind up going, and all of a sudden it hit the next cylinder of the firing where it's like kind of hitting a brick wall. Okay. And that slowed the speed of the crankshaft down right here. Okay. So I can make that inferral. So that also backs up my starter motor current. All right. So I got to find number 1. All right. We know it's 43 teeth. So you know what I'm going to do? I'm going to count these teeth. Okay. I could use Pico, but I can count it by hand. And I'm going to walk this thing back here. Okay. Or what I could do, I can say, hey, it's 2 compression starter motor humps. Okay. Before the cam sensor. All right. But I on these Fords, the 6064, this is how I do it. Okay. And I jump in here. I'm going to do it the modern way too. I could count, but I'm going to go in here and go to measurements. I'm going to ask the scope to do a rising edge count, because me to sit here and count this, I'm going to need another prescription at Lens Crafters. Okay. It's going to be a little harder to do. All right. So we're going to go ahead and use this rising edge count. And I'm going to tell the scope, okay, I'm going to drop a cursor here and I'm going to move this cursor, because I'm going to tell it, I'm not going to show you exactly how to do this. I'm sorry, but I'm just going to give you a rundown that I want to check the number of teeth between the cursors. I'm going to drop a cursor at the missing gap, and then I'm going to move this so I get it where I want it. Okay, and that's basically what I'm telling you. I'm going to take this other vertical cursor. I'm going to walk it over till I get to 43. Okay, and this is where I'm at. You see, I got 43. I've walked this over. The scope is counted for me. I walk it right here, and I can infer that this is number 1 cylinder. Okay. That's what I can infer. All right. So, and typically, you might ask, well, Chris, that starter current hump looks a little bit to the right or a little retarded. Yeah. Remember, this is where my injector fired. Typically, most engines fire before top dead center. I'm sure you'd agree. I know I showed you a gas engine, it seems like 5 hours ago, that fired a little bit after, which is normal too. But I know that this is number 1 starter. Excuse me. This is number 1 cylinder starter motor current hump. I know that. Okay. So I'm a phase ruler guy. It's easy on my eyes. Okay. I jump in here. All right. I do the same thing. Turn them on. I got 8 cylinders. I'm going to use these little arrows right here. I'm going to drag this in between these and make it so I got 8. So this is my 720 degrees. I'm going to drag this into position. Okay. And I do that. Okay. And I put it in here. And now I know, okay, now this is easier on my eyes. Now I know now I just got to dump my firing order in. Okay. So I dump my firing order in. Okay. It's at 1, 2, 7, 3, 4, 5, 6, 8, 1. Okay. Who doesn't have any compression? 4. Same thing as scan tool tool. I mean, it took me a little bit of work to do this. I could still do this in under 15 minutes, believe me. Okay. But I know I have a mechanical problem. Okay. There's no fuel injector in the world that's going to solve this. There's no standardine treatment that's going to solve this. You get where I'm coming from here? You get where I'm coming from? Okay. I mean, we see this. Swap. You see when we start swapping injectors, you see how that's a complete waste of time? Complete waste of time. I know a lot of you guys love Swaptronics and moving stuff around. We are just wasting time here. How do we build a customer for that? Okay, especially on a 6.4, not an easy engine to work on anything. I don't care if it's a TerraStar International or an F350. These things are a pain. These things are the worst, okay, in my opinion, to get to. The component accessibility is just horrible. Absolutely horrible. So number 4, he's my guy. He's my guy. Okay. And you know what? Remember I said 60 amps is my minimum? I brought my horizontal cursors in. What do I got? I got a 290 amp difference from top to bottom. Would you say that's a significant amount of current? All right. This thing is no bueno. No bueno. All the way. Okay. I got a serious problem here. So I kind of want to know what the problem is. Okay. I could have a leaky valve. Could have a leaky exhaust valve, could have a leaky intake valve. That's true. I can't figure out who that is with cranking current. Okay, more than likely. All right. But you know what I can do? I can do a crankcase pressure test. All right. And hey, it's a 6.4 that's chipped up. I'm sure you already got an idea where I'm going with this. Okay. So what does Ford have to say about crankcase pressure? So if I go to the Ford service manual, they tell me, hey, Chris, we're saying it's got to have less than 10 inches of water. Okay. All right. And you need to buy this fancy 303 dash whatever it is. I think I had it in there. I'm sorry, 303 758. Okay. And it's got a magnehelic gauge. It's got some other gauges, fuel pressure. And you know what? If you were a Ford dealer in 1985, you probably got this shipped to you with the old 6.9 IDI engines. Okay. But not many of us have access to this. Okay. Now, can I go and get a magnehelic gauge and get this adapter? Okay. They've got an adapter that goes right over the oil fill housing. You know, if you guys have worked on that Max 47 6.4 liter, they've got this big oil catcher device. I can't think of the word off the top of my head. I'm sorry, but there's like an oil collector for the crankcase fumes that dumps into the air filter line. Okay, so that's what this thing connects to. All right. So what I'm going to do is I don't own any of that stuff, and chances are you don't either. But you know what? I've got a smoke machine in our shop. Okay, and I've got this Pico pressure transducer that I talked to you about, and we're going to use this to our advantage. All right. So what I'm going to do is I'm going to connect the low amp because this thing runs. I'm going to do a running crankcase pressure test here is what I'm going to do. All right, because I'm wondering if this thing has a crankcase leak in cylinder number 4. That's what I'm wondering. Okay, it's kind of like my friend Eric Ziegler says. You know, you design an experiment. Okay, the experiment on a design is like, okay, I'm going to shove this pressure transducer in the crankcase oil fill. All right, and I'm going to try to line up crankcase pressure pulses to an ignition event, in this case a fuel injector, and see if there's a correlation there. That's what I want to know. Okay, and I can ID what cylinder it's on. That's what I'm attempting to do here. Okay, so I'm going to set my range to plus or minus 5 psi, because remember what Ford says, anything under 10 inches of water is good. Now that's above RPM. It's at 3,000 RPM. I'm going to do this test as idle. Okay, I'm going to take my amp clamper on number 1 injector, and I'm just going to run this engine for about 10 seconds. All right. And here's my amp clamp, and I know it's kind of cloudy here, my iPhone. It was focusing on the wrong thing. Evidently, it liked that number 72 hose clamp better than it liked the connector on the valve cover. But this is the right bank valve cover where number 1 cylinder is located. And by the way, I can go to any cylinder because I can input my firing order after that. Okay, so I don't necessarily care if it's number 1. Number 1 is easy because everything starts with number 1 in my world. Okay, so this connector stares me in the face. I didn't have to take the air filter or anything out. And I'm going to go around a wire, okay? And I just happen a number 1 injector wire. Remember, there's 2 of them, okay? And I picked the positive green-blue wire because this is a piezo injector, all right? So I clamped around there, and then here's my Pico transducer with my smoke machine funnel, okay? You probably could go on the dipstick tube with this too, and you'll see the star of the show is this spark plug boot. I love old spark plug boots on my transducer because I learned this many years ago from a friend of mine that these things will go over anything, okay? And when I put this thing over anything, it works great. Okay, I can put it over dipstick. I can put it over PCV valves. When I do, if you guys have watched my engine mechanical class with gasoline engines a while back, you'll see me use that. I put that in the intake manifold, all kinds of places. Okay, if you see me do boat stuff, you'll see where I tie that into fuel lines between the fuel tank and the engine to look for fuel restrictions. All right, but anyway, I'm on range 3 here, just to give you an idea where I'm at, and I got the smoke machine funnel jammed into the oil fill cap. Okay. Now this is a video. I think this is going to play for you. All right. You know, you're hearing my lovely voice. This is a truck. Okay. And I got Pico here, and I'm going to play this real quick. And it's basically me starting up the truck and shutting it off. This is how quickly I got this information. That's all I ran that truck. You see, this is where I started up. That's number 1 injector. And this is my crankcase pressure. So if I look in here, I didn't run this thing, 12 seconds? 12 seconds. Remember, it's diagnosed in 15 minutes. I got what I need here in 12 seconds. I mean, yeah, I had a little bit of setup time, but everything I need is right here. All right. So let's zoom in. Let's look at this. Okay. You already know this is my number 1 injector. You know this is my crankcase pressure. I see something going on here. It looks like I got some spikes, all right, on my red crankcase pressure. I zoom in. Remember, this is number 1. This is number 1. This is number 1. Okay. I put some arrows in there because something catches my eye. I've got these sharp pulses that repeat. You heard the truck. I mean, it started, it ran, all right? And I'm just, like I said, I got my Pico WPS 500X transducer jammed in the oil fill cap, okay? Well, let's break this down. And I want to break this down because I'm coming right here, number 1 cylinder, is right here, number one cylinder. All right, that's 720 degrees. You already know where I'm going with this. I'm going to use my phase rulers. Okay, I'm going to line up my phase rulers in between that. That's 720 degrees crankshaft rotation. And I measure with a horizontal cursor, I measure 0.318 psi. Okay, now remember the Ford spec is inches of water. Okay, now I don't know about you. I'm not the smartest guy in the world. Okay, so I just go to Google and I Google, hey, what is psi to inches of water? And I basically punch in 3.318 and it automatically calculates it to 8.81 inches of water, which is what I want to know. Okay, so that's where that came from. Now that's under my spec. Now remember that spec was at 3,000 RPM. The spec was nothing over 10 at 3,000 RPM, but I got 8 inches of pressure at that short amount of time. All right, just run at 12 seconds. That's another no bueno here. Let's see if I can ID what's going on here. Remember, number 4's got our contribution code. All right, and I pop my firing order in here, and the reason I can pop my firing order in easily is because I've been using my phase rulers. So I know my firing orders 1, 2, 7, 3, 4, 5, 6, 8. I pop these in right here. Boom, 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 boom. I know what's up. And look at this. That's where number 4 is supposed to fire. Okay. We're going to use the piston position chart next, but I can kind of infer something here. We know that the injector fires right here. Okay. Don't you agree that the piston, number 4 piston's coming up on compression stroke right there? Okay. This thing's got a cracked piston hole in the piston cylinder wall problem. Would you agree that's when crankcase pressure is going to show up in the crankcase? When that piston goes up on its bore and it's leaking, it's hemorrhaging air, hemorrhaging compression, and it's going past the rings, past the cylinder wall, or through the center of the piston? Okay. And you see how it dissipates right after number 4 fires. And it repeats. You know, I'll go back here. You can see this thing repeats, and it repeats in the same area. Repeat, 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 repeat. It's not onesie twosie. It's a repeat all day. Okay. So if I want to know a little bit more, we can use these piston position charts. You see me use these before. You can get these from Drivability guys. Again, this is not a commercial. This is just what I use. They're $20. They overlay right in, and it kind of hits my point. Okay. And I expand this piston position chart across my pattern. Okay. And let's take a look here. All right. And I shaded this in yellow because this is number 4's compression stroke right here. Okay, I zoom in a little bit better so it's easier on your eyes. Number 4's compression stroke approximately starts right here and it ends right here. Boom, this is where the injector fired. Okay, so we know the piston approximately. Again, this is not a degree wheel. We don't have a dial indicator in here. Okay, this is not exacto, but it's close. All right, close enough for me to make a diagnostic decision. And when I see this piston, right, that's halfway up the bore approximately, and that's when we really start to build compression. Wouldn't you agree? We don't build compression when the piston's at the bottom half. We start to build compression half all the way up. That's when we start to build compression in an engine, okay? And you can see this thing pressure come right up here. But what happened? Didn't the fuel injector fire right around here? All right, and it might have had some compression. I don't know. I never checked it. Don't care, okay? But I go in here and this thing fired and it just dissipates right out. And then it repeats. So what does that tell me? Is this a leaky intake valve? Is this a leaky exhaust valve? No. This thing's got a short block problem, okay, or a blown head gasket to the crankcase, I guess. But it's chipped up. We know the story. It's got performance modifications. It's got a cracked piston or whatever, okay. So we inferred that says we can tell our customer, look, we know number 4 basically has nothing. We didn't take the glow plugs out. Okay, I'm not doing that. It's too much work. Okay, we could have done that, but guess what? If we would have done that old school compression gauge or compression test with a gauge, all that's going to confirm is I got no compression. It's not going to tell me where the leak is. Now, could I have rigged up air and put air in the cylinder? But don't I have to find where TDC is? Okay. How am I going to do that? An engine that's got no timing marks. You're working on a 6.4 with that big fan stator in there. Do you think you can get anywhere near that crank pulley? And you know those internationals, they got 4 bolts. They don't have a bolt in the center. So you've got a 19 or I think it's 18 millimeter. I forgot the size, 18, 19 millimeter socket. And you're trying to work on one of those 4 bolts. And it sucks. Okay. you would have one heck of a time trying to get that piston at TDC to do a proper leak down test. It's going to take me way longer to figure that out than this. Okay. I'm sure you agree with me. If you've been there, I'm sure you have. It's not a fun day. Okay. It's a lot of work. And we don't know if we're getting the job, by the way. Okay. So I don't want to spend a bunch of time on something that we may not be putting an engine in or rebuilding an engine. Okay. So you know what? We told them what was wrong. We confirmed what the other shop thought was wrong after they put injector in it. And we said, you know what, sir? This thing's got a crankcase lease, more than likely a cracked piston. We didn't put a bore scope in it. And he says, you know what? After the cold shower, he was donezo. He's like, you know what? I'm not fixing it. I'm junking the truck. I don't want to put any money in it. But you know what? We got our hourly diagnostic fee. I'm not bragging here. I'm just telling you the truth. We got our hourly diagnostic fee, and we maybe spent a half hour total from pulling the thing in to doing this test. We might have had a half hour invested. Okay, the whole thing. And the testing was obviously less than 15 minutes. But it was really, really good testing. Okay, and I couldn't have done that testing, in my opinion, any more efficiently unless I use a scope and a pressure transducer. I don't think there's any way I could have done it. Even if I did the Ford way, it's going to take a lot more time. Okay, to get this. I'm not saying doing the old way you can't get the same results. You can, but I feel these results are as accurate or more accurate, and done in a short amount of time. I can do the next job. That's how you make money in a shop is getting the vehicles in and out, right? Boom, 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 boom. The more vehicles I can get out, the more money we can make. Okay, in theory. Sometimes it doesn't work that way, but you get the idea. And my last one I want to talk about, I got a Duramax here. Okay. You can see here, Carfax clean owner. It's got Florida Georgia line, probably still playing in the speakers. It's probably got the nuts hanging off the trailer hitch. Okay, it's jacked up. It's got the whole smash. Okay, it's got Kraco 6x9 speakers blasting. You got it. Okay, and it's got a misfire number one cylinder. It's an LML. It's a 2015. And I'm going to do the same basic thing I did here with the Ford. Okay, and I got a misfire. It's chipped up. We already know that. And I go to All Data, and All Data tells me, hey, Chris, they have a slightly higher spec. They say, Chris, no more than 16 inches of water at 3,100 RPM. Okay, that's the only spec I could find in the OEM service information. This is All Data, but it's a GM document here. Okay, but that's what they said. Okay, so I'm like, okay, so let's put this to work. All right, I got number one cylinder. Okay, I got my amp clamp there. I'm just cutting right to the chase. No sense to bore you with the details. You can see that I've got some kind of repeatable pattern here. Okay, and I measure it. I've got 4.5 inches of water, which is under the spec. Again, I'm not at 3,000 RPM. Okay, I'm not at the RPM they specify. All right, but I got a misfire in number one cylinder. That's my argument. I got a misfire in number one cylinder. Do I want to try to get that glow plug out of that Duramax? No, I don't want to do that. Could it be a leaky valve? Of course. Okay, it could be a leaky valve. But you know what? I take my pressure transducer and I put it in the dipstick hole. Okay, so I took the pressure. I didn't take pictures of this. I apologize. This is before I thought I was going to do anything with this stuff. But I take the dipstick and I take my spark plug boot. I went right over the dipstick and I scoped number one injector current. Okay, and I fired the truck up. I let it run. It's idling at 650 RPM. I get this pattern that repeats. I shut it off. All right, you already know what I'm doing. I use my piston position, or excuse me, I use the phase rulers. It tells me the firing order. I know this is number one. I can put the firing order in. All right, it's 1, 2, 7, 8, 4, 5, 6, 3 in this Duramax, and I can see that I start to have a rise in pressure on number one's compression stroke, and number one's compression stroke is right here. Okay, I didn't mark this one up on purpose because I wanted to show you without the markings that you can make this determination. And you know what? Think of it this way: do I need a piston position chart? Necessarily no. If I know that the pressure's starting to rise at or about, doesn't that look kind of very similar to my Ford, that I still had a peak of pressure after the injector fired? You know, I know this thing's got a piston problem. It's not an exhaust valve. It's not an intake valve. And you know what? In diagnostics, knowing what it isn't is just as good as knowing what it is sometimes. If I can rule out things like this, like if this would have passed, like if I'd have rolled this thing over and I didn't have much or crankcase pressure in this thing, no, I know I got a head problem. You know what? At that point, it's probably worth pulling the heads. But you know what? I'm not lifting the cap or pulling the engine or anything. I'm not pulling the head for this, agreed? Because I know the pan's got to come off, or it might have cylinder wall damage or whatever. Okay? I know this is a short block problem. That's all I know. Okay? And it's more than likely a piston because it's shipped up, hopped up, and all that stuff. So Just to give you a heads up on how we do that. But don't you think that's kind of interesting? You think it's kind of easy to do? You got to make an investment, okay? And obviously, the pressure was below the GM published spec. Again, I wasn't at the RPM. Okay, it's misfiring on number one cylinder. Scan tool told me that. Okay, I went and did this crankcase pressure test. I did a relative compression. It failed. Okay, but I wasn't going to go through all that again because we only got 2 hours. All right, and I did this. The truck had a cracked number one piston. The customer did not opt for us to fix it. He's going to take it to his buddy where and fix it, which is fine. But again, we got our diagnostic fee. We didn't take anything apart. The worst thing I did was get on there and get the injector. I got my I got my cam sensor signal so I could verify compression. Because on a Tech 2 or a GDS 2, to my knowledge, there's no relative compression on these GM trucks. Ford, you can do it. I don't think there is on Chrysler too. I don't think there's one on O.A.E.V.T on the 5.9 Cummins and so forth. But you can do this stuff. And that's why I say the scan tools are nice, but sometimes I got to get a scope out. There's nothing wrong with getting a scope out. So basically, that's going to conclude what I've got to do or say. I hope you enjoyed it, but I got a couple things I do like to plug here. If you like everything I just did, okay, coming up here in Ohio, I'm going to have a live event. Okay, it's at the Ohio Association of Emergency Vehicle Technicians Symposium. They have a training symposium in Reynoldsburg, Ohio. It's a suburb east of Columbus off I-70. Okay. And it's basically on emergency vehicles. Most of the folks that come to this, it's open to the public, okay? But most of the folks that come to this are going to be municipalities, City of Cleveland, City of Columbus, that type of thing. Okay, guys that are working on fleets, fire trucks, ambulances, cop cars, that kind of stuff. Okay, but this fee is really reasonable. I mean, there's a week of training. It's $625 for the week. Includes a cafeteria lunch every day. You're going to think you're in high school again, and the food's good. They have specials. That is included for that price. Or you can take individual classes at $250. All right. If you don't have time to spend the whole week, you can go to oavte.org to sign up. This is coming up here in a couple weeks. I'm going to be doing a broader version of what you just saw with gas and diesel engines with hands-on. We're going to be in a lab. And we're actually going to put this stuff to work. So if you want to get your hands dirty, you want to see this in action, and you're near me, or you want to come up and see me or whatever, you're more than welcome to do it. This is a place you can do it. These fine folks at O.A.E.V.T would love to have you. Okay, and it's at the Ohio Fire Academy. You can contact me. You've got my email address, or you can go to the website and sign up or whatever. But I just want to mention that if you want some hands-on, this is a good spot to do it. And also, if you're into Marine, okay, I do this at EHOVE Career Center. Okay, I have a week-long class. It's 4 days. I got a 4-day long class on the scope. Okay, and I still can't cover everything. I gave you a very watered-down version in 2 hours, the best I could. Okay, but if you want some of this on marine engines, which is what I kind of started out doing with this. I mean, I worked on this stuff on cars first, and then I transitioned to the marine side because nobody was doing the marine stuff, so that's why I went that route too. But we have marine engines, and I don't care if it's a marine engine in a I don't care if it's an engine in a combine or a marine engine or a semi truck or an 8V92 Detroit or whatever. A lot of stuff I told you, we can apply it to all kinds of stuff, as you can see. So we have these engines in a lab. We usually do morning lecture, afternoons, and we talk about diagnosing engines that don't run right. We have techniques on setting up a scope to capture stalls and cutouts and communication networks, all kinds of stuff. We spend 1 day on engine mechanical. Okay, which is basically what we're doing here for AERA. All right, but I'm pretty much done. You can always reach out to me. Here's my email address. Okay, Chris H at LakelandAutoMarine.com. You got any comments, questions, concerns, whatever? If you want some information on the scope, you want to send me patterns or something, have me evaluate it. When I get time, I respond to all that stuff. I may not respond to you right away, but I'll do my best. And I appreciate you guys for attending. I hope you enjoyed it. I hope you got something out of the 2 hours or so that you spent out of your day. And we have our Facebook page. Okay, you can check that out. We have a YouTube channel. When I get time, I try to put stuff on that. Mostly marine engine rebuilding, stuff like that. Just a little snippet of what we do. I'm getting ready to post a Chrysler 273 video. We just did a 1973 Lyman. We just sea trialed yesterday, actually, out here on Lake Erie. So there's all kinds of interesting stuff out there. So with that said, I'm pretty much done. Are there any questions or anything from anyone?
Chris, I mean, awesome presentation. That was like I say, that was you've done a lot of work there with all those case studies and everything, and we're getting nothing but great feedback and lots of, as you can see on your screen there, everybody's really happy with the work that you've done, and they're very pleased with it. So what we're going to do is any questions that you've got for Chris, if you have any questions, you're going to be able to fill them out afterwards and put them in the survey that Amanda's going to talk to you about. And what we'll do is we'll pass those questions over if you have any. And we appreciate everybody's time. Chris, especially yours. Like I say, I mean, man, I know you go just head over heels just trying to get this stuff together, and we definitely appreciate everything you do for us. So thanks again.
You're very welcome. I can't see any of the questions. None of the questions or anything popped up for me, so I don't know. None of that stuff I was able to see. But no, I appreciate everyone's time. You know, as you can see, I'm kind of passionate about this stuff. I want to help people, you know, get better at this. You know, it's not fun sometimes being a mechanic, but you know, I think techniques and technology like this kind of make our jobs easier. I mean, to me, this is fun. I enjoy this stuff, and I appreciate 8ERA giving me a platform to do it. You know, when you guys ask me to do this stuff, that's why I do it. So.
No, super. And like I say, I mean, this will be out on our YouTube channel, which Amanda will explain to you as well here in the next few slides. If you want to, you know, there'll be a link also. So if you want to catch any of this information again, you'll be able to see it on all kinds of different channels, like I say, through YouTube. Any questions for Chris, we'll make sure to get them over to him. And yeah, great info. Chris, if we're not talking to you, you have a good rest of your long weekend coming up. And again, we appreciate your time.
No, thanks. Thank you, everybody. Thank you for your time. Thanks, Rob and Amanda. And I hope you guys have a great Labor Day weekend and be safe.
Super. So what I'll do is I will go back to Amanda and we'll get things to, we'll wind things up for you.
All right, we'll keep this quick for you guys. First off, if you haven't already, go out and subscribe to our YouTube channel. As Rob mentioned, we post all our webinars out there. We've got our Engine Professional podcast is out there. We did Viewpoint with Dennis Quaid. There are a couple teasers out there, more to be coming, including our commercial. That is going live this month, so watch for that episode. There's some business content out there, just all sorts of great things. Process tutorials for our Process Pro software. Take some time and check it out. And then, as Rob mentioned, this webinar will be up there probably after the holiday weekend. So look for that one to be posted sometime next week. And with that, if you need to reach anyone on the 8ERA team, you can reach us at 815-526-7600. Or if you need to, you can always shoot either Rob or myself an email. You can see both of our email addresses are there. We're always happy to help, and if we don't have the answers, we'll pass you along to somebody on the team who does. So thank you, everybody, for taking time out of your day. We know how busy you guys are. We really appreciate it, and we hope you all have a great rest of your